تمام.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، الصلاة والسلام على أشرف الأنبياء والمرسلين، أما بعد. السلام عليكم ورحمة الله وبركاته. يسعدني نيابة عن رئيس الجمعية السعودية في جامعة إكستر الأستاذ سامي بن محمد المالكي وأعضاء الفريق العاملين معه في هذه السنة أن أرحب بكم أجمل ترحيب، وأن أرحب بشكل خاص بزميلنا وصديقنا الأستاذ أحمد العبري ممثلا من الجمعية العمانية بجامعة إكستر، وليقدم لنا هذه الدورة في هذا المساء عن مقدمة عن البرنامج الإحصائي المشهور spss، والذي نسأل الله سبحانه وتعالى أن ينفعنا وإياكم بهذا العمل، وأن لا يحرمنا الأجر والثواب في الدنيا والآخرة. لا أريد أن أطيل عليكم كثيرا، فالأستاذ أحمد سيبدأ معكم هذه المحاضرة باللغة الإنجليزية، ويرحب بأي استفسارات بأي لغة سواء العربية أو الإنجليزية، فأهلا وسهلا بك يا أستاذ أحمد.
Thank you very much for the beautiful introduction. I don't think I will need the microphone. So thank you for the wonderful introduction. My name is Ahmed. I'm a PhD student. This is my final year. I'm conducting a mixed method research. So SPSS is part also of my analysis. So let's start first. This workshop. This is only an introduction to SPSS. There are a lot of things or details for more advanced levels for students. So let's start the introduction first with explaining the acronym here, SPSS. It stands for Statistical Package of Social Sciences. And in this workshop, we'll cover these topics. First, we'll come across the different types of variables. This is very important because when we come to enter data manually into SPSS, you need to verify the variables. Whether the variables, we'll come across these. There are 4 variables. Also, we need to come across the types of statistics with some explanation and examples. This will also lead us to choosing the right statistical test. Then we come to preparing, before we carry out or execute any statistical test, we need to prepare or qualify the SPSS data file for the analysis. So the preparation of the file includes cleaning data, starting with also replacing missing data, recording negatively worded statements. This is very important. Also assessing skill reliability. Mainly here we are talking about internal consistency. There are different types of reliability. Mainly here we are talking about internal consistency. We'll also, after that, we'll come to summing the variables. The summed variables are continuous, or we call them also scale variables. Then we'll assess the data distribution, we call it normality. After that, we'll decide, after we finish the normality test, based on the results we get, we'll decide on whether to go for parametric or non-parametric tests, or even to go for them both. It depends on the results. Then we'll choose the result. Once we get whether to go for parametric or non-parametric, then we'll choose the right statistical test. It depends on the type of variables we have. Then also we'll apply the test. This will be in practice, understanding the test results, calculating the effect size, and also reporting the results. Do we need to stick to the ways of reporting results found in the books, or we have different things to report? This will come across. Also, we come at the end before we come up with questions for the next workshops. This is only introductory. So let's start with the different types of variables. We have 4 types of variables. These variables call them categorical variables. Also we call them nominal. We have ordinal variables. Also we have interval. And the last one we call ratio variable. So what do you mean by categorical or nominal variables? Also called nominal variables. These categories are a variable with levels. When we say levels, I mean rules. Because we come to, for example, we talk about gender level. Gender level has two levels, female and male. So when I come to the word levels, I mean rules. Okay? The order of this level is not important. So when we come to enter the data into an spss, I'll give 1 to female. Get it? 2 to male. The order here is not important. I can give 1 to female and 2 to male. So the opposite is right. So the numbering here has no importance of order. Get it? It's just giving it an order, or just it's just the value here was just for giving a name for the category, 1 or 2. So the order here of the variables is not important. Example, as I said to you, gender, and also questions, yes, no questions. Did you study last night? If I give you this as a survey, yes or no? Get it? So I can give 1 to no, 2 to yes, or the opposite is right. For example, I give 1 to no and 2 to yes. So the number does not give order, just giving it for the sake of giving a name to the category. The second one is order, or ordinal variables. From its name, ordinal, means the values you give to the variables indicate order. Get it? So it also takes the properties of categorical. Here we see they are categorical. For example, let's see, for example, educational level. We have what? Diploma, bachelor, master, PhD, these categories. Yes? But the order of these categories is important. So that's why we call it ordinal. So it includes or it takes the properties of categorical variables plus the order is important. This is we call it ordinal. The other one is called interval. Interval or variable is a measurement variable where the difference between every two values is meaningful. For example, you can give an example here. For example, temperature degree. We have 20 degrees, 40. So for example, when I say, for example, to you, 90 minus 80 equals 10. It's the same like 50 minus 40, which is 10. So the difference between every two variables is what is equal or meaningful. Get it? That's what we call it, interval. Like also, I'm giving you here, but the temperature degrees here expressed in Fahrenheit or Celsius. I'll come also again to temperature in Kelvin. But here Kelvin is not interval, we'll call it ratio. Why? We'll come across that. So the last one we call it ratio variable. Ratio variable has all the properties of interval properties. So the properties here are cumulative. So every variable accumulates all the properties of the predecessor variables. So plus it has the properties of the interval variables. What here? It has clear definition of 0.0. What do you mean by 0.0 means here absence or no existence of that variable. I come across again to interval. When I say to you, for example, the degree, the temperature degree now is 0 Fahrenheit. Does 0 no heat? Temperature is 0. Does it mean there is no heat? No. Does not mean there is no heat. So the 0 here with interval variable does not mean the absence of the variable. Get it? But here With ratio, no. 0 means no existence or none of that variable. That variable or its characteristic is absent. Get it? This is the difference between the two variables. I'll give you an example of ratio. For example, height. If height is 0, that means that the variable is not there. Yes? Or it's there.
It's not there.
It's not there. That's why we call it ratio. Also, weight. If someone is with 0, that means that person does not exist. Get it? So weight is also, if 0 means the non-existence of that variable. Also, enzyme activity. If no enzyme activity, that means that person is almost dead. Temperature degrees, but here expressed in Kelvin. So the Kelvin gives us the degree of 0.0 means no heat. But if temperature degree is expressed in Fahrenheit or Celsius, does not mean heat is not there. Get it? So this is the difference between interval variables and ratio. Knowing the differences between these variables is very important, as I told you, when coming to enter data into SPSS. If you are not able to differentiate between this, then you are in a way harming your data analysis, even the results you get. So you are harming even the quality of the results you get from the test you apply. Now let's come across the different types of statistics. We have two types of statistics. The first one we call them descriptive statistics, and the other one is inferential statistics. Descriptive statistics, from its name, is for describing, for giving description of something. If you have one person here, and I say to you, describe it, you will very easily describe that person. But what if you have 100 or 1,000 individuals? How would you describe these? How would you describe a sample of many or several individuals? How would you describe it? You use descriptive statistics. Descriptive statistics describe a large volume of data into fewer values. These values expressed as standard deviations, means, medians, modes, ranges, and even the normality is considered also what describing, because they're describing the distribution of data. Thus, it helps us identify errors in data. When we come, as I told you, one of the first steps in preparing your data file for analysis is to clean it. How we clean it? By running descriptive statistics. Descriptive statistics will tell us, for example, the percentage of missing data, whether you have violated or entered a value by mistake. For example, for gender, 1 male, 2 female. If you enter data manually, there is a chance you make a mistake. Instead of entering 1 or 2, you might enter 3. How we find out about this error is by running descriptive statistics. We can execute the descriptive analysis through descriptive and frequencies commands with the SPSS. Do you know what I mean by mean, mode? We have taken this at school. Mean means what? The sum of cases values divided by the number of cases. I'll give you an example. Mode, the most frequently occurring value. Median, the middle value in the data set. So the median value separates the data into two halves. And that's why it's in the middle. It's called median. Range is the highest value, maximum, minus the minimum, the lowest value. This will give us the range. We have taken this at school. Standard deviation is what we talk about standard deviation, but do we know what I mean by standard deviation? Standard deviation, we have a mean and we have scores. So the standard deviation describes the distance scores separate or get away from the mean. That's called deviate. You know what's mean deviate? You are going straight, then suddenly you deviate. That's why it's called deviation. You call it standard deviation. Deviation with what? Deviation of the scores describe the set of scores, the relation of the set of scores to the mean. Get it? In relation to the mean. Outliers is also very important to check, what we are not going to check in this lecture because it takes time a little bit. So the values that have higher or lower than the rest of values. So you have some values, sometimes you have 5, 3, 1, 2. You have this set of values. You find one value or 3 values or whatever the number is, values, separate from the group of values. This we call them outliers. So they can be higher than the rest of values or lower than the rest of values. So let's have a quiz here for the median. Who can give me the mean here? Just explain. We don't need to calculate. We can calculate it, but how do we calculate the mean here? The mean here, how many? We have how many cases here?
6,
1,
7, 8.
2, 3, 4,
8.
5, 6, 7, 8. So that we mean we
Take
have
the sum.
8 cases. Just sum up these values. So 15 plus 15 plus 15
45.
plus 20 plus 20 plus 22, 21, 25, 36. What's the sum? So the result you get divided by the number of cases, which is 8. The result, we get the mean. Okay, we have also median. Look at the definition and just do the calculation. Median is the middle value in the data set that divides the value into 2 halves. What's the value here? What's the value? And to know this value, first you need to put the values in order. Put them in. These are in order. I have already put them in order. So what's the value in the middle? That
20.
separates. I do it in this way. Here we have 8 values, which is even number, divided by 2. 4. This is number 4. Get it? But count the numbers before 20. 1, 2, 3. But here 1, 2, 3, 4. But then it is not in the middle. Here, when the values, when the number is even, take the 2 values in the middle. So the two values in the middle was 20, 20. But you need to take one value. What you need to divide them. 20 plus 20 divided by 2, 20. You get 20. So the median here is what? 20. Mode. The most frequently occurring value. What's the most frequently occurring value here? What's the number is most repeatedly happening?
15. 15 and 15.
15.
15.
3 times.
So the mode is what? 15. Range, the highest value minus the lowest value. So what's the highest value? 36 and the lowest?
15.
So 36 minus 15 equals 16. Not 16.
21.
21.
Yeah, 21. Equals 21. So this is a very quick quiz. The next we talk about descriptive statistics. So they describe a volume of values, a volume of data into fewer values. So it's easier for us to understand. The other type is inferential statistics. Inferential statistics, it allows researchers to make inferences and generalization about the study population. based on the analysis of data sets withdrawn from the study sample. So we study the study sample to make generalizations, inferences about the study population. That's what we call inferential, coming from the word infer. So infer. So we use statistics to infer results about the study population. But how able we are, or are we, in making generalizations? Is it enough for inferential statistics to say to us, just now stop, you get the result, now just generalize it? No. Generalization here is not only based on the inferential statistics results. The study sample size is also affecting whether you will be, to what extent you are able to generalize. So the study sample size. Sampling method. Well, I'm not going to cover these, but I'm just telling you for your information. What things that makes us generalize, what power we get in generalization. These things are affected by, or generalization is affected by the study sample size, sampling method, how have you sampled your individuals in the study. So the way you use in sampling your study, putting them in your study, it affects the result and affects whether you are able to make generalization or not. So sampling method is very important. Results of normality, whether data is normally distributed or not. Also choosing the right statistical test. If you are not choosing the right statistical test, you will wrong results. So you want to be able to generalize. Most of this information are not in other workshops. I have worked on this just to make things or to give new things to students, instead of just digging into books to find these or find such information. Let's now go to inferential statistics. They are grouped into two groups. Statistical techniques to explore relations among variables. These include correlation. We explain what we mean by correlation. It's very important. Partial correlation, multiple regression, logistic regression, factor analysis, because you have a set of variables. Most of these variables are what? Scarce, continuous variables. You don't have one or two continuous variables. You have a set. You can have one, two, then you use correlation. Get it? So the more these variables there, you use different tests. But most of these are what? Continuous variables. What test you use, it depends how many continuous variables you have. Statistical techniques to compare between groups. You have two groups and you want to compare between them. For example, between males and females in an achievement test. For example, math. Get it? You want to compare them. We use this for these tests. So how do we compare statistics? Compare groups using what? Using means. Using means. We have t-tests here. One-way ANOVA. Two-way ANOVA. We come across these and others. Correlation. Do you have an idea about correlation? Correlation is firstly used to explore the strength and direction of the relationship between, this is very important, between two dependent continuous variables. As I told you first. That's why I told you from the beginning, it's very important to know to differentiate between the different types of variables. If these two continuous variables mean scores, about numbers, rates. So that's why they call it continuous. This is very important. A lot of students make mistakes about this. Number of smoked cigarettes, heartbeat rates. What's the relationship between the number of smoked cigarettes and heartbeat rates. If you apply correlation test with test, it should tell us the more number of cigarettes you smoke, the worse heartbeat you get. Get it? What do you notice? One goes up, the other goes down. Get it? This is tell us what the direction of the relationship. We'll come across that. Confidence in English language use. And I have here a question here. The question is that I sent to you. It talks about confidence in English language use. So at the end I will get score, means. Get it? That means continuous what? Continuous variable. And we have communication apprehension. Also I have another question here to measure communication apprehension. So I got two means. Get it? Compare how to get the numbers. How to compare, how to know the relationship between them, I use correlation test. Autism and life satisfaction, self-efficacy in English language use, and intercultural interactions. I said here what? No dependent. No independent variables in the correlation. No independent. What do you mean no independent? Do you know what the difference between independent and dependent variables? Dependent variables that all the changes happens in the dependent variable. All these changes caused by the dependent, independent. So independent variables don't change. All changes happen with the dependent variables. For example, we have male and female. So you expect yourself once you finish the lecture, you become a male?
No way.
Or males?
Yeah, exactly.
No, these are, we call them, they will not change. So that's why we call them independent. Get it? So that's the relationship. The correlation only tests the relationship of two continuous variables. Thus, no causation in correlation. No, I'm giving you all these details because other students have problems with correlation. It's very easy to apply using SPSS, but I'm spending more time about the theory behind it. So no causation in correlation. What does mean no causation? In causation, a relationship we have cause and effect. Get it? If there is a cause, there is an effect. If there is an effect, there is a cause. So if this relationship is not there in correlation. So we cannot, for example, we cannot guarantee. This is what I mean by no causation. There is no guarantee that, for example, let's say, for example, self-efficacy in English language use and intercultural interactions. Get it? There is no, here, if people have higher self-efficacy in English language use, these students should have more intercultural interactions, yes? But if their self-efficacy here does not guarantee, because if the students are not interacting with people from other cultures, are not interacting, this not tells me that this is because they don't have good English. Get it? Get the point? So here, the self-efficacy does not cause, although it contributes, but it does not cause it. Even when there seems to be a clear cause-effect relationship, correlation alone is not sufficient evidence for a causal relationship. A third variable, why there is no causation? Because we have said what we have independent variables, dependent variables, and we have confounding variables. Variables interfere with these variables. So the interfering variables may cause changes here in this relationship. Okay? So a third variable may interfere in explaining the association between the two major variables. Let me give you an example. for more clarification. There may be a correlation between the two numbers. Here I'm talking about the number of ice cream sold and the number of people who drawn. Here, what I cannot say here, people, I cannot, maybe there will association between the numbers. See, I'm talking about numbers. See, numbers, number, continuous variables. I cannot say here what the relationship between the number of ice cream sold and the number of people. Maybe people buying ice cream because of temperature. Get it? The temperature is a possible variable causing this association between what ice cream and the number of people. Get the point? So that's why we call this no causation. I can, for example, here now I come across partial correlation. In partial correlation, we have here the number of ice cream as one independent, as one continuous variable, and the other continuous variable is the number of people who drawn. Okay, who drawn. And I can put temperature here. I control it. I will not let it affect this relationship and see whether this association will be still there or not. I can do this using partial correlation. I come across this, but this is the next terms. The parametric test for this correlation test is Pearson product moment correlation, or just Pearson correlation. It's parametric test. As I told you, what the correlation tell us what about the strength and direction. The strength indicated by the numbers here. We have a range from -1 to 1. -1 to 1. The number itself, without minus or plus, get it? The number itself tells us the strength of the relationship. Plus or minus tell us the direction. If there is plus, what does mean plus here? Plus means there is what? Positive correlation. Positive correlation means if one variable increases, the other variable increases. Positive or negative correlation is what? If one variable increases, the other variable decreases. Get it? For example, the number of cigarettes. If the number increases, if the number of cigarettes increases, get it? What? The heartbeat decrease. Get it? Or it's in this way. Even if you have, for example, less or low level of self-efficacy or confidence in English, we expect you to have what? Less communication or less interaction. This way we call it what? It depends. So when variable goes increases, the other decreases. This is what negative correlation. If both increases, then this is what positive. And we have here the numbers. It's here. And we have here what criteria for strength. If the correlation here is what the highest is 1. The highest is 1. And here we have ranges of strength. So if the correlation are this, the result of this, from 0.1 to this is the range you can use it when you explain or analyze your data. I'm giving it here just to save your time. A perfect correlation of 1 or -1 indicates that the value of one variable can be determined, predicted, exactly by knowing the value in the other variable, but again, no causation. So I'm giving you here, again here for positive correlation again, confidence in English language use and self-satisfaction. If you have high kind of confidence in English, then you are expected to have high self-satisfaction. If you have higher abilities of speaking, then you have high confidence in communication. So both increases. For negative correlation, then I've already given you this. For example, here also the more instruction in English, the less linguistic mistakes committed. The number metric for the correlation is what? Spearman's rank order correlation. I've already talked about partial. Did you get the point about the partial correlation? Did you get the point about partial correlation? It's the same like the normal correlation, but you have a third variable which you control. Why are you controlling it? Just to make sure whether it's still there association between the main continuous variables. Now, go again to I don't know, sky or chai or the chi-square for independent. With correlation, I talked about what? About two continuous variables. Continuous variables, numbers. Here I don't have numbers. Here I have categories. I have what? Categories. Here I cannot apply correlation. I don't have numbers. I have groups. So I have what? Similar to correlation, but in it the number of cases in each category is considered, not the scores, no continuous variables. Again, we have two variables, but these two variables are not continuous, categorical. I'll give you an example. So one categorical independent like gender. Get it? One categorical, I think that I'm spending more time on theory. It's more important than applying the test itself. You can open any book and just follow the steps for applying these tests. But if you are not, you don't know knowledge which test to go for, then spss will not benefit you. Get it? So following the steps how to conduct or how to do or execute the test is not as important as knowing the knowledge of what test to go for. This is very important. Continuous variable can be two categorical here. I have what? Gender category, not numbers. And the other category dependent what? Drop out. I'm giving you a survey and I say to you, just indicate your gender. You say, for example, male or female. And you say, have you dropped from the therapy? I'm giving you a therapy. And I say to you, have you dropped out from it or out of the therapy? You say, no or yes. No or yes, that means you have two groups. Group of students who have dropped out and those who have not dropped out. Get it? So I have here categories. I want to know the relationship. Who has dropped more than the other? Male or female? Here I cannot, I have two variables, but these two variables are not continuous, categorical. Here I use what? Chi-square. But if I have, for example, I'm giving you here a question. Get it? I'm going in depth for more information. Drop here, I'm giving it to you as what? As a question in the survey. But also I can turn drop out here variable into continuous. I can transfer into continuous. How? For example, I have a sheet of absence or this, and every time you come, if you attend the class, whether you are there or not, I take dropped out or this. Then I count on these I get the means of these scores. So at the end I get what? A mean, a score. So that score means what? Continuous variable. Yes? In this case, what? I have gender as categorical and drop out as what? As continuous. Here, what test I use? What test shall we go for? Here I will go for t-test. That's why I see the importance of knowing, being able to differentiate between variables. Here I have two categorical. I can send this to you. And no need just to take a short of the slides. I have added this question in the survey I sent to you about the age, how to transfer continuous into groups. So I'm saying why I have given you this example, and I said we can transfer it. I'm giving you this because the way you present the variable determines the test you will go for. If you present it as category, get it? You will go for another test. If you present both variables as scores, means you go for another variable. Get it? For example, here this question: what's the relationship between gender and dropout rate? Another way, are male more likely to drop out of therapy than female? We test. Since this is gender, categorical variable, and dropout categorical, then we go for chi-square. Do you want a break or continue?
Let us to continue for half an hour.
This is the theoretical.
This theory, as I told you, I'm focusing more on theory because it's more important than from the practice. So if you have the ability to determine what test you go for, that's it.
How many slides?
I don't know, maybe 11 or left. I don't know how many slides left.
For the theoretical part only.
Yes, this is only theory. We don't have slides for SPSS. For the SPSS, we'll have a data SPSS file. We'll work on it.
Okay.
T-tests. For the t-test, why do we use t-test? To compare means of two independent groups or conditions. To determine, why do you compare between them? To determine whether the two means are significantly different from one another. For example, I have gender. I'll give you examples later on. But we have here three types of t-test. The first one, the easiest one, is one sample t-test. Determines whether the observed mean, you have a sample, and you get a sample, from that sample you get a mean. And you have another mean of a population, you get it from somewhere. And you compare between them. Whether the mean you get from your sample significantly different from the one of that of study population or not. But I've rarely seen the researchers using this one. Most people, or most students or researchers use these two.
In social science, they use the second and the third one. But I think in medical, they use the first one.
Mostly.
Yeah.
I don't know. Independent sample seed. It's called independent sample seed test. Also, it's called what? Independent t-test. Independent. What do you mean by independent? Different. When I say to you, independent samples means different samples, different groups, male, female. Dropped out, yes, dropped out, no drop out. Get it? Two groups. The equivalent non-parametric is Mann-Whitney. We use it when comparing means from two different groups of individuals. To carry out or to execute this, what do we need? A variable with two independent levels. When you hear me saying independent levels, means independent or two different what? Groups. When you see the word level, it means group. Get it? And a continuous variable. A categorical group. Categorical group with three levels, or two levels, two groups. I want to compare between males and females in math achievement test. Get it? So I'll achieve them. Have two groups and one continuous variable. Paired sample t-test is called paired. Paired samples mean the same individuals, the same group. So I'm giving, for example, I'm giving you today as a test, or a questionnaire. Then after, for example, 1 month, I'll give you the same questionnaire again. So I'm giving the same test to the same people or individuals, but on different occasions. Get it? So here I don't have here two different groups. I have the same group, but I've given the test or the survey on 2 different times or occasions. Not necessarily 2 times, 2 occasions.
Here, there's a question here, if you allowed me to ask.
Please ask. I like people or students who...
Yeah, you mentioned for the non-parametric test, but what about the parametric test itself?
Parametric?
Yep.
Here we are talking about, these are one sample t-test, independent, these are all parametric tests.
Yeah, but there is a non-parametric you mentioned.
This non-parametric tests, these are here with the parametric, we'll come this, when to determine whether to go for parametric or non-parametric.
Yeah, there are 4.
When we do the normality test.
There are 4 conditions, I think, to decide go to the parametric or non-parametric.
Can you explain them?
Let us to see. Do you have it in the next slide, or can we describe it?
We talk about normality.
Yeah, the normality.
But in general, parametric tests assume that there is linearity.
Yeah.
In the relationship between them. But if with the non-parametric, no, there is no linear relationship between the variables. So mostly with the non-parametric test, they always, you will hear the word what rank order, because the non-parametrics use what to rank data, rank them. But with the independent here, no, they use means rather than ranking. We will come across this. So we use paired sample tests when comparing the means of 2 sets of observation scores from the same individuals. For example, giving the same individual the same survey at 2 different times or occasions. I have used these 2 in my study because I'm doing pre-post. Again, it depends how you present the variables. For example, in my study, I'm doing pre-post. Get it? In pre-post, I'm supposed to use what? I'm supposed to use paired sample t-test, but I'm not using paired sample t-test. I'm using independent sample t-test. I have my own reason. Get it? I'm just telling you again, how you present the variable, it depends whether to go for this or this. It depends how you present the variable, how you present your data. Get it? This is very important. In effective size, why do we need to learn about effective size? Sometimes we get the effective size tell us the difference between 2 means. Get it? Whether the difference between, for example, male and female, high, large, or small, or medium. Why do we use this? Especially when we get significant results, significant difference. I'm not interested only if there is significant difference. I'm interested also in seeing the magnitude of the differences between the means. Whether the difference between measure is small, medium, or large. This is also what I'm interested in, not just whether there is a significant difference or not. At Across, we have 2 types of how to calculate effective size. We have Cohen's D and eta squared. Eta squared ranges from 0 to 1. If you get a range from point 2 and till, for example, 2.04, it's very small. The size between the 2 means is very small. From 5 and before 0.8, formula is here. I have already given you. Looking for it. But also, I use in my research. I use eta squared instead of Cohen's D. It's here what. With Cohen's represent the difference between the groups in terms of standard deviations units. But with eta squared present the proportion of variance, the magnitude of difference in between the means. So here I use these, and also you have these criteria to determine whether the difference between the 2 means is small, medium, moderate, or large. and also I'm giving you this. This formula is for the independent test. Why we have N1 and 2? Because we have two groups. And minus 2 because we have two groups. Here it's the same, but we have one group. Bear t-test. We have one group, the same group. So n minus 1. This is the difference. Why we have here 2n and 1. Analysis of variance. Analysis of variance is like the t-test again. But what's the difference here? With the t-test, we have what? Yes, one independent variable with two levels. With one-way ANOVA, one way means one factor. One factor with more than two levels. With more than two levels. That means 3 and above. I'm giving you an example. For example, educational level. Educational level, I have how many groups? For example, 3. Diploma, let's say for example, bachelor, master, PhD. 3 groups. Okay. What if I have two?
T-test.
T-test. Get it? Independent. Here I have 3 levels, 3 groups. Then I go for one-way ANOVA. So one categorical independent variable with more than 2 different levels, more than 2, 3, or more than 2 different groups. Okay. As well as one continuous dependent variable. Continuous variable. For example, I compare them. I compare between, for example, bachelor, master, and PhD students in math achievement. Get it? If I compare between 2 groups in math, then I use what? T-test. So the number of variables is also, the number of variable and the number of levels is also important. Continuous here. For example, also year of study. Year 1, year 2. If I use year 2, then what? T-test. If you have continuous variable as a dependent. But here I have year 1, year 2, year 3, year 4, year 5, year 6. One way ANOVA. Use one more than 2, whether it is 3, 4, 5, 6. At the end you have one variable with more than 2 levels. You have what? ANOVA. The non-parametric test for this is called Kruskal-Wallis test. We have also one-way repeated. One-way repeated is like Baird t-test. It's like Baird t-test. Some students, and even I have seen some even teachers, they explain this in a wrong way. One-way repeated means like saying Baird. That means what? Instead, let's say requirement one categorical independent variable with more than 2 levels. The same people on 2 different occasions. The same people on 2 different occasions, like Baird t-test. But here I have more than 2 levels. Get it? As well as one continuous dependent. So it's ANOVA, one-way ANOVA, but it's repeated. Like for example, pre-test and post-test. Get it? Something. Okay. The sum of squares. How to calculate the eta square? The sum here. All these values are given in the tables we look at. You just need what to get a calculator and divide this by this. That's it. So the sum of squares between groups divided by total will give you what? The eta square. The magnitude of difference between the mean scores. Two-way between groups ANOVA. Some teachers they call they say what the non-parametric test Friedman is for this. No, Friedman test is for this, not for two-way between groups ANOVA. Here two-way. What do you mean two-way? What do you mean by one way? They said
One variable.
No, one way means one factor.
Factor.
One independent level, one independent variable. Is it? With more than 3. Here I have 2 way. What does it mean? 2
Independent variable.
independent variables. So one of them, here what to say 2 categorical independent variables with 2 or more levels. 2. For example, age, group, and gender. For example, age group I have 3 levels, but gender not necessary to have 3. Only 2 is enough. But the most important is what? To have 2 independent variables. You put them in the test all together, as well as one continuous dependent variable. Like for example, study journey satisfactions to school. I'm giving you a question, for example, about your study journey satisfaction, whether you are satisfied about your study journey or not. Get it? So I put age groups and instead of studying this separately, get it? Applying 2 tests at 2 different times. No, I put them all together and apply 1 test, which is what? 2 way between. And this also will give you what? Also will you see how they interact with the dependent variable. 2 or more groups for each home. 2 or more groups for each independent variable, and different individuals in each group. Different individuals or different groups means different individuals. The non-parametric test, there is no non-parametric test for let's then only about we have about 3 slides or 4 maximum.
Yeah.
Normality. What do you mean by normality?
The normal distribution between the data, the means, the STD allocation.
It tells us how the shape of the distribution of our data. In general, why call it normal distribution? I run the normality test. I hope all my data should get this shape. Get it? So what if I get this shape, then I need to use what? Parametric test. Because then, but as I said, parametric test makes us what? Give us the ability to make inferences or generalization about the study population. If my study, if my normal distributed is not like this, for example, say I have skipped some slides for your sake. So, for example, this has given us what? This is not normally distributed. It is what? Positively skewed. Positively skewed. Here also what is positive, here it's what? Negatively skewed. What do you mean negatively skewed? The means or the data is pushed in one direction. Positively means pushed in this to the left. When I say negatively skewed, it's pushed to the right. To understand these very well, I'll give you another example about wealth distribution. If we talk about wealth distribution, what shape do you expect? Yes, I expect this one. Because I expect this one. Because what most people nowadays are getting what? Getting poorer. Most people are, yes, even the moderate society, the moderate people with moderate income, with the life expenses, they are coming poor.
So it will be positive or negative?
There is positive skew in this one. So most these will be here. Get it?
Yeah.
If I give you, for example, if you are all smart, if you are all coming from rich families, and I give you a questionnaire about wealth, then I expect you all to be here. Get it? That's what does mean this one? This means that does not. This shape is away or significantly different from normal distribution. Significantly different from normal distribution. And this one also. So I cannot generalize, but does this always happen? If I get, for example, this shape, does it always tell me that I cannot generalize my data? So this is new information for you. Even if you get this and this, you can generalize your data. It depends. It depends on some.
In case it represents
some conditions will come across them.
In case they represent the population of the study.
This does not represent. This shape does not represent normal distribution. Does not represent the study population. And this one normal distribution. Will come, but from here, if you get this one, no. You get this one, no. Just forget about with condition. You can generalize with conditions. So the result from so how would we know whether our data is normally distributed? We get a table we call normality test results, and we'll show it. If the result, if p value less than 0.5, it indicates what there is what the data distribution in my sample is significantly different from the normal distribution. Here you use what? Non-parametric tests. We use non-parametric tests. If the results what equals or greater than 0.5, that means what? There is the distribution of my data is what is not statistically different from the normal distribution. That means it's similar. That means it is what we use what? Non-parametric. However, the size, as I told you, the size of the sample affects the result you get from the normality test. The larger the sample becomes, the more likely the results of normality test becomes what? Significant. Indicating that the data are not normally distributed. So the larger your sample becomes, there's a chance that the result you get from the result what? Significant. Indicating what your data is not normally distributed. In this case, it's not enough. It's not enough only to look at the results you get from the normality test itself. This is not enough. What you need to look at, you need to look what? For the z-scores. You look for the skewness and kurtosis. Skewness, I told you, whether the score is pushed in one direction or not. Significantly positively skewed or negatively skewed. Kurtosis means whether it is all the data dialed and it's pointing. For the z-score should be in this range. Should be in this range. If you're B, you are sitting in the B at 0.05. The z-score should be here, in this range. If the score is beyond this range, then it is what? Not normally distributed. Then it is not normally distributed. Moreover, again here, the largest sample, the significant test of skew are more likely to be significant, even when the skew and kurtosis are not too different from normal. This is because of the large sample. So instead of just focusing, as I told you, on the results of the normality, look at the kurtosis, the z-scores, plus look at what. Make sure whether it's normally distributed by looking at what. Look here. Check the z-score whether they are within the range. Examine the shape of the distribution visually and see whether it is normally shaped or normal distributed or not. Get it? Look at the shape or the graph visually. Look at it. See whether it is normal distributed or not. Also look at the histogram to make more assurance. Look at the histograms, PD or QQ blocks. These are all produced when you run the normality test for more assurance. Get it? Because a lot of students just focus on the results of the normality test, only whether it is significant or not. No, if your sample is small, yes, it's okay. But if you have large sample, no, it's not enough. Look or make sure from you checking the distribution visually, and also check also the PD or QQ plots. So here for example, I think we explained this. Or we explained this is QNS kurtosis. This is normal. See, this is what is very dull. This is not normal distribution. I'll just go outside. So we have 2 slides already. Internal consistency are the other things you need to check before running any statistical test. You need to check the reliability of the instrument you are using. So mostly when you are using, the most commonly used is the internal consistency, which is alpha value, or Crumbach's alpha. What do you mean by internal consistency? Internal consistency, what it measures what to what extent or the interrelatedness or the correlation among the variables or the items in the scale. Get it? So I'm talking here about correlation. But here, for example, I have an instrument. For example, I have 10. The one I sent to you, it has about 2 instruments. In total, I have 20 items. Can I run correlation here? No, because I have more than, for correlation, normal correlation, I have 2 continuous. But here I have 20 items, 20 continuous variables. So reliability internal consistency test is a kind of correlation. So when you say the reliability internal consistency of my scale is high, means the items are highly interrelated to each other or not. This is what the level of reliability is determined by the strength of Crumbach alpha. With higher Crumbach coefficient indicate a higher level of reliability. And here are some questions for, these are more advanced workshops. The first question, and here some mistakes that there are some common mistakes committed by students. Whether the students are master or even PhD students, committing common mistakes. What are the factors that affect alpha coefficient value? We need to understand this, but these are not for today, for the coming workshops. Is reliability the ultimate goal of scale construction? A lot of students just measure or assess the reliability of the test, and that's it. Is reliability in its own a goal? How is scale validity checked by SPSS? Is it adequate to check the normality of just total scores of continuous? Here we check the normality distribution by adding what? By entering the totals into the system. Is that enough? Is it enough to determine the representativeness of the study sample from just the normal distribution of our data? So I have got normal distribution of data in my sample. Does that make me sure that my sample is representative of the study population? No, I've answered this question at the beginning. I said sample size also affects the generalizability of the data and all these things, plus the normality result. No. What are the common mistakes in scale construction? There are very common mistakes when coming. A lot of students commit when coming to construct a scale when they come to build a survey. What's the common mistake in skill validation? These are all questions we answer in the coming workshops. So this is all for the theoretical part of this workshop. I think we have a break now, then we'll download the slide. Just run very quickly some of these tests. Okay?
Take some questions, 2 minutes, 3 minutes.
Yes, do you have questions? I forget. Any questions? I think not clear.
You can discuss the
Mostly I have asked all this question because I'm a student. I have raised all these questions before, so I have good answers for them.
Can I suggest
So that's why I present. Yes?
to discuss the questions that you mentioned about it in the previous slide? Yeah. Yeah, you mentioned about many
No,
questions
these
here.
questions for the coming.
Try to discuss with them maybe these more important questions. What is the common mistake in scale validation or something? What are these common mistakes?
Okay. I'll give you some answers to these questions.
Yeah.
It's not enough just to, for example, it's not enough just to check reliability of a scale. Reliability on its own is not a goal. It's not a goal. The goal from scale construction is to reach validity, to achieve validity within your scale. There are a lot of factors affecting the reliability.
Yeah.
One of these, for example, the number of items in the scale. So the more items you have in the scale, it's more likely the reliability will be higher.
It's the same thing happened with
If
the
you have
alpha.
if you have less items in the scale, it's most commonly will get less reliability. So the number of items affects the strength. Get it? That's why some researchers don't consider it a goal in itself. High reliability also, for example, what do you mean by validity? What do you mean by validity? Scale validity. Scale validity means the scale measures one thing, one construct, one trait, one characteristic. Get it? Does your scale measure one characteristic? Yes, I know you have given to some doctors to check it for you. They said it's okay, it's measuring, but you also need to check it in more depth using SPSS. And to check this, we use factor analysis. We need to make sure that your scale is unidimensional. What do you mean unidimensional? It's measuring one dimension, one construct. Get it? So getting high reliability does not mean your scale is measuring one thing. Get it? So to make sure whether your scale is unidimensional, we need to run factor analysis. So this is one of the common mistakes when coming to scale validation. This is only one answer of many other points raised. For what are the common mistakes in scale construction? I can give you. There are many mistakes, several mistakes. One of these, the students mix between the Likert scale. For example, they have strongly disagree, agree or disagree, neutral, agree, strongly agree. Yes? And when they come to write the item, then they say what? I often read every. For example, I try to come with an item they always include frequency adverbs. I always feel confident in my interactions. I often, most of them. What do you mean? So often, always are ambiguous in meaning. So when, for example, CT, what do you mean by always? Do you always 6 times a day or 6 hours a day? So we will give me a different answer than others. So it does not have a specific meaning. This is one mistake. The other Likert scale with agreement, disagreement, I'm asking you whether you agree or disagree. I'm not asking you about how often you do these things. So when you integrate both scales in this, you are contradicting yourself. And most of these mistakes are committed by students. Either these students are master or PhD students. This answer, the rest of answer I'll give it to you in the coming.
Do you have any questions, my colleagues, before taking the break for 15 minutes? Simon? Simon, do you have a question?
No, fine.
Now we will take a break, 15 minutes.
I give them just another common mistake.
Okay.
For example, also when I say to you, for example, I included this mistake in the survey I give to you. When I say I am nervous, I am intense and nervous. Intense and nervous. So you are adding two adjectives. Two adjectives does not have the same meaning. So when I ask this, give this statement to a student, you will spend a lot of time to give me an answer to that item, whether you agree or you don't agree or not. Why? Because you are thinking of two adjectives. If you agree, for example, with one adjective, you might not necessarily agree with the other. Get it? So this common mistake is called paralleling. So you need to avoid paralleling in writing items in your surveys. And the rest, we can
Okay, thank you so much. Now we will take a break, 15 minutes, then I think we will start to analyze.
Yes, I think let them take 15 minutes.
Yeah, it's okay.
To
15.
download the file.
All right.
There are two files, I think. Yes. There's an SPSS file and Word document. The Word document is the surveys. The SPSS is the data I have collected from you.
Yeah. Check down.
Most of the errors you get in the SPSS file, most of the time you get them if you enter the data manually. For example, if you have distributed the survey in a form of paper. So I'll give you, for example, the survey in paper. You responded and you give it the paper back to me. In this case, there is a more chance that you make errors in entering the data. While these mistakes or these errors are avoided if you collect data online. Is it? All you need to do with online data is just download the file. And if you have missing data, you just replace the missing data. So mostly in this file, we will get errors. But I will show you how to check that. Ready?
Yeah, great.
So I would like you to open the survey and also the SSP file. So I have here, see, so this is we call this number one a case. This is case. These are cases. Cases, when you say case, means individual. So since you have responded, like I have a file about you, so that file I call it case. Get it? So I have here 25 cases. That means 25 students have taken the survey. Here, all these we call them variables. All these we call them variables. You can change. You see here, you have this all the writing here in writing. All the responses are presented in writing. You can also present them in numbers by pressing here. You see when A, whether you do them in letters or in digits, in values. These are values. So how to check? First, we need to check for the errors. For the errors, if you see the survey here, for the demographic questions, categorical variables, how do you check them? We check them using the frequency command. How to go there? Let's go. Go to analyze, descriptive statistics, frequencies. Here we have frequencies and descriptive. We use frequencies for the categorical, get it? But for the scale variables, the scales mean that you have responded to. We'll use descriptive. So I will enter the categorical variables, educational level, gender. I have not entered age. Age till now it is not categorical because you have entered your age. So I have now numbers. So now the age now is considered continuous variable. Continuous variable. So I will not enter it now. I need to transform it into categories. I will show you how to transform continuous variable into a categorical variable or nominal variable. So I go to statistics and choose mean, median, mode, minimum, maximum, and standard deviation. Mean, median, mode, standard deviation, mean, and maximum. And press continue. And press also again continue. See for the age. So now all they have here, what we have right now descriptive statistics. What are descriptive frequencies? See here missing data. We didn't have missing data for the variable what? Length of your hair, all the variables here. How many, student, how many we have?